Section 12.2 is on geometric sequences and series. So like we talked about arithmetic sequences and series being using addition and subtraction, geometric sequences and series use multiplication and division. So when we look at the list of these numbers here, we want to think using multiplication or division, how am I getting from one number to the next? Well, 2,000 is half of 4,000, 1,000 is half of 2,000, 500 half of 1,000, and so on. So every time I'm getting from one number to the next, I'm dividing by 2 or multiplying by a half. Either way you can look at that. So the pattern here is we are multiplying by 1/2 to get from one number to the next. So if we take 250 times 1/2, the next number in the sequence is going to be 125. So the definition of a geometric sequence is a sequence in which each term after the first term, which we still call a sub 1, is the product of the preceding term and the common ratio. So we had a common difference in arithmetic series, 1/2 is going to be called the common ratio for geometric series. So it's the same idea. We have the first term, a1. We're going to take that term and multiply it by the common ratio. We're going to take that term and multiply the common ratio again, so it'll look like a sub 1 r squared. And again, we just keep taking the preceding term and multiplying by the common ratio. So what we want to do is to find the nth term, or a sub n, of a geometric sequence. We're going to use a formula. Now this has an extra formula. This formula also works, but we're not going to use this one. We're going to just stick with this one here that says a sub n equals a sub 1 times r to the n minus 1. So again, a sub 1 is just the first term in the sequence. R is the common ratio. And n is the number term that we are looking at, or the last term. We can think of it as a last term as well. So if we want to look at these sequences here, sometimes you need to use this formula and sometimes you really don't need to, depending on what you're trying to find. So we want to find the next two terms in the geometric sequence. So what we want to do is we want to observe what's happening between one number to the next. Well, to get to 4 to 16, I multiply by 4. To get to 16 to 64, I multiply by 4. So our common ratio, or our r in this case, is going to be 4. Another way we can figure that out is because it's a ratio and we're multiplying each term by the same thing, we can take the second term divided by the first term, and that'll always give us our common ratio. So if we take 16 divided by 4, we get 4, which is the same r we observed. So I found r. 4 is a sub 1. And I want the next two terms. So I don't actually really need to use my formula. I can just say, well, 64 times 4 is going to be 256. And 256 times 4 is going to be 1,024. So in this case, I can just use multiplication to find the next two terms. Leave that down a little. Okay, number 2 says, write the first 6 terms in the geometric sequence if a1 equals 4 and r equals 3. So, again, we want the first 6 terms, and I don't necessarily need to use my formula for this. So I'm going to say my first term is 4. That's the first term. I'm looking for the second, third, fourth, fifth, sixth terms. So this is a sub 1, this is a sub 6, and I know my r is 3. So all I'm doing from one term to the next is multiplying by 3. So I can easily just fill this in, just doing some simple math in my head. So 4 times 3 is 12, times 3 is 36, times 3 is 108, times 3 is 324, times 3 is 972. Number 3 says we want to find the nth term of a geometric series where a sub 4 is 10, n is 5, and r is 1/2. So we are finding the nth term in the series. In this case, when they give us a sub 4 is 10 and n is 5, we are actually looking for the 5th term because n is 5. So if a sub 4 is 10, and I know r is 1/2, a sub 4 is 10, then I'm going to have a sub 5. If r is 1/2, then all I need to do to get from the 4th term to the 5th term is multiply 10 by 1/2, which gives me 5. If I wanted to use the formula, all I would say here is I have a sub n equals a sub 1 times r to the n minus 1. So I can easily just use my formula here as well. If I work backwards, right, instead of multiplying by 1/2, I'm going to multiply by 2 to go backwards. A sub 3 would be 20, a sub 2 would be 40, and a sub 1 would be 80. So in this case, if I'm looking for a sub 5, my first term would be 80, r is still 1/2, n is 5, so n minus 1 would be 4. When I multiply this out, I get 80. 1 to the 4th is 1, 2 to the 4th is 16, and I do that division and I get 5. So either way, you can find the common ratio either just by observation or by using the formula. So I would like you to try this next one. Find the mth term of the geometric series where a sub 6 equals 5, n equals 9, and r equals 3. So again, you can either use the formula or you can just use your logical thinking skills and work it out on your own. I'd like to see some work on this. The answer, however, a sub 9, should be 135. So see if you can get that. Just like we had arithmetic means, we also have geometric means. So again, that's finding missing terms between two given terms. So we want to find, and we do this very similar to arithmetic series. So we want to find the three geometric means between 4 and 324. So we have 4, there's 3 numbers we're missing, and then 324. 4 is a sub 1, this is a sub 2, 3, 4, and 5, which means our n is going to be 5. R is what we're looking for, our common ratio, so we can figure out how to get these three numbers. But we're going to use our formula, which says a sub n, which is 324, equals a sub 1, which is 4, times r to the n minus 1. N is 5, so n minus 1 is 4. I'm going to divide both sides by 4. I get 81 equals r to the 4th. When I 4th root both sides, I get r equals 3. So with r equals 3, I'm just going to multiply by 3 here. That's going to give me 12, 36, and 108. Okay, and again, a geometric series now is taking a geometric sequence and just adding up each term to get a sum. So we have another formula that we want to look at. The sum of a geometric sequence is given by S sub n, which takes the first term minus the first term times r to the n over 1 minus r. So for example, we want to find the sum of the first 8 terms in the geometric series, 14, negative 70, positive 350, minus 1750, and so on. So we want the first 8 terms. That means n equals 8. The first term is going to be 14. That's the number I'm given first. And then I want to find r. Remember, you can find r by saying a sub 2 over a sub 1. That's negative 70 over 14, which should give you negative 5. So when I have a sub 1, n, and 5, I can use, I have all the variables that I need for my formula here. So I'm just going to plug this in. S sub 8 equals my first term minus my first term times r, negative 5, to the n, which is 8, all over 1 minus r, which is negative 5. This just requires some simplification. So I'm going to have 14 minus 14. This 8 to the this negative 5 to the 8th needs to stay together. So you need to figure out what that is on its own. That's going to be 390625 all over 6. Just plug that into your calculator and do some simplification. You should get negative 911,456. That's the sum of the first 8 terms of that geometric series. So again, you try this next one on your own, doing the exact same thing we just did. Your answer should be negative 236,192. Please see if you can get that.